Hello, everyone. I'm Arul Jegadish, the co-founder and CEO of Observability. So, good morning, good afternoon, good evening to everyone. Today, I'm going to talk about next-gen log analytics with ClickHouse and Kafka. Before we jump into the topic, a little bit about Observability. Observability is a DevOps tools platform. We provide a fully managed ecosystem of curated DevOps tools. And one of the modules in our platform is a full stack observability solution. And as part of that, we have a log analytics module. So this session is about our learnings when we went about implementing this module. So let's dive into the session. So before we go into the other details, a quick question for all of you. Do you use logs? How many of you here use logs? Like when you write code, like how many of you print out logs? When you run your applications in production, how many times do you go look at the logs to debug? Probably all the time, and all of you. Maybe I should frame this question in a different way. Like, is there anyone here who doesn't use logs? Probably no one. So logs are everywhere. In fact, they are the simplest form of telemetry. If you look at all different types of telemetry signals like metrics, traces, profiles, logs are probably the simplest form of telemetry, and almost everyone uses them. But the issue with logs is logs are very verbose, they're unstructured. Even though there are now structures emerging as JSON, log format, etc., but they are by and large very, very unstructured. And because of this, they're hard to search. Like if you need to create a good indexing and search engine over all your logs, that's going to take a lot of compute, and it's going to be pretty complex. And it's even harder to run analytics on top of your logs because of this reason. And especially if you're thinking about real-time analytics, real-time aggregations, it's pretty harder. You're looking at like really complex systems. So when you look at the open source ecosystem, like what are all the options that we have available as of now? You have the Elasticsearch and OpenSearch type of tools. They're actually pretty good for analytics. But the downside is they are pretty complex and costly. And especially if your log volumes all of a sudden like increase 10x, then you have a real problem. Then your complexity and cost of infrastructure also goes up 10x. On the other hand, we have tools like Grafana Loki. They're pretty cost effective because Loki keeps all your logs directly on like S3 type storage, and it can query directly out of S3. But the downside is they're not suitable for analytics, especially a tool like Loki. If you run a log search across like one entire week, for example, if that's your date range, Loki doesn't do really well. And now if you have to run aggregations on top of that, Loki is not the optimal tool. So what we need now is a cost-effective yet scalable analytics solution for logs. So the rest of the session, we are going to look at one option in order to bring in like real-time scalable analytics on top of your log data set. So for that, we're going to use like two popular open source tools, Kafka and ClickHouse. So the solution that I'm going to describe is going to be based on Kafka and ClickHouse. At a very high level, the simple data pipeline is going to look like this. I have demonstrated two options to collect log. On one hand, you could use an existing log collector like FluentD or FluentBit running in your infrastructure to directly ingest that log into Kafka. FluentD has an out plugin that can actually ingest the collected log data into Kafka. The other option is, let's assume that you already have an existing log solution like Grafana Loki, and maybe a subset of that logs that are present there, you want to run some real-time analytics. In that case, you'll need a small custom ingester that can actually read logs, query logs from Loki, and ingest those logs into Kafka. The advantage of having a custom ingester is you can actually maybe enrich the data, transform the data, or filter out data if required. You can add some structure also to the data, and before you dump it into Kafka. And on the right hand side, we have ClickHouse. In this proposal, in this discussion, we're gonna use ClickHouse for pretty much your rest of the data pipeline, where like how you would consume data from Kafka, consume logs from Kafka, and how you transform that and finally like aggregate it and query that data. We're gonna look at we're gonna try to do all of that within ClickHouse. All right, and within ClickHouse, like some of the features that we'll use in this proposal, we'll use the JSON data type, JSON fields. We'll use the Kafka table engine. There's an interesting table engine. If you haven't tried that, you should definitely try that out. Then we'll use materialized view to transform the data that's collected into the Kafka engine into a like a merge tree type engine. And finally, we'll also see how to make use of like aggregated merge tree engines in order to like pre-aggregate your data and then like query your data. All right. Again, at a very high level, this is how the data flow looks like. So you have Kafka and you have Kafka topic. Think of it as one Kafka topic per log stream that you want to ingest. And then everything else is within ClickHouse. So the beauty of the solution is like you don't have too many moving parts. You have Kafka, which is pretty standard infrastructure component in any environment nowadays. And then you have ClickHouse, and within ClickHouse, you manage the rest of the data transformation. So the first thing is you create a Kafka table engine, and that's the connection between Kafka and your ClickHouse. And that's the table engine is going to do the heavy lifting of consuming Kafka messages from the configure topic and bringing it into ClickHouse. Then you have a materialized view that actually transforms the data from here into a normal like merge tree family of table. So you can actually read directly from this table as well, the Kafka, the table created using Kafka table engine. But what's going to happen is it's going to consume those log messages from Kafka, and then like you'll not be able to read those messages again. So it's usually you would usually consume those messages using a materialized view and then querying out of this table. Then you have an aggregated merge tree. Actually, you would insert another materialized view here to transform this data into an aggregated merge tree. And over there, you'll be able to like set all your pre-aggregations. And your queries, all your aggregation related queries will happen from here. You will have the data accessible here if you want to do like free text search and or any other data query. I also want to make a note here that this is slightly different than like using ClickHouse full on as a log management engine, which is also a common use case nowadays. There are some big organizations out there who actually use ClickHouse as their like log engine. So the schema considerations will be slightly different in that case. But otherwise, that is also a possible solution. You could use a very similar data pipeline to actually bring in and use ClickHouse as your full-on log management solution instead of something like Elasticsearch or Loki. That's also possible. All right. So now the next section we're gonna look at some examples of how this will all be when you actually implement it. So for the implementation, I have taken like Istio logs as an example. So I have a Kubernetes cluster where I have Istio service mesh running, and as part of Istio, I have an ingress gateway, which is the ingress for all connections that come into that cluster. So I collected that log, and we'll see like how you can take it through the ClickHouse pipeline. So going back to my slide here, so in my case here, I already have a Grafana Loki where my Istio logs are available. So what I do is I have this little custom ingester that queries Grafana Loki, and then basically for each line it creates a Kafka message and then dumps it into Kafka. And the message format is pretty straightforward, where it has a, let's see if this has a, yeah, the message format's really gonna be, there is a um, the message log line, the timestamp, and um, basically the list of labels or tags attached to each log line. That's really what's coming as part of the Kafka message. And if you look at this table, this uses the Kafka engine, and the parameters here basically take care of like configuring, like where is my Kafka. In this case, my Kafka is running like within the same cluster, so I'm able to just use the Kafka service name. I'm giving a name to the stream, the Kafka topic, and this is like the consumer name. So that's all you need to do. Once you do this, this is going to take care of reading your Kafka topic and bringing data into ClickHouse. Now, once it comes into ClickHouse, there are two things you would do. There is a materialized view that reads from the Kafka engine table, and that actually inserts data into this particular table, which is a merge tree table. So over here is where we are going to transform the list of labels as a JSON data type. So because when we ingest, especially when you're querying from Loki, your data is actually, all your labels come in as key value pair. So ClickHouse in this case converts that key value pair string into a JSON data type, and then we capture the timestamp and the log line, whether it's structured or unstructured. We just capture the log line here. So with this materialized view and table, now you have whatever comes into Kafka will actually end up on this table for you to query. So with that, like, you have the data like in ClickHouse. So that's pretty much the ingestion pipeline. You don't really have to bring in any other tools into the mix. You'll be able to get data into ClickHouse using ClickHouse native features. And then the next step is, now if you want to like aggregate this data, pre-aggregate, so then you can actually create aggregating merge tree and an associated materialized view to get data into the aggregated merge tree. So in this case, like the labels actually contain a lot of useful data with respect to every request that's coming in. It's like the response code, the host name, the timestamp, the path, whatnot. Like, it has all context about requests coming in. So you can actually use the aggregated merge tree to pre-aggregate, like create, for example, you can pre-aggregate the P90, P75, P50 in this case of latency, the average latency, the number of requests coming in, and you can actually group by like the path and the host name and authority and response code. So this is an example where now, even if you get like billions and billions of transactions or log lines coming into ClickHouse, this will be very, very fast. And the aggregated merge tree doesn't take much space on disk as well. So you'll be able to get data. You'll be able to like create really high performing dashboards out of this data. Um, and again, like the biggest advantage here is, even if your data range is really high, even if you are going to query out of like billions of records, this scales really well. And it's not a very costly solution because of the ClickHouse compression, and especially the aggregated merge tree does a really good job of compressing data. So that's what I wanted to like present as a high level solution here. This is something, if you want to try out, you can very easily try it out even on your laptop, with both Kafka and ClickHouse running on your laptop. You'll be able to very easily put it together. There is, if you go to the ClickHouse doc pages, there is actually a couple of doc pages around consuming Kafka data within ClickHouse. There are actually multiple ways to do that. I picked one way, which is the Kafka table engine. So you can actually go explore the other ways of bringing in Kafka data into ClickHouse. Initially, when I started using the Kafka table engine, I had a feeling that this is more like a toy feature. It might not scale, but this actually scales very well. And recently, I saw a blog from Lyft where they actually use the Kafka table engine heavily. So that means it scales really, really well. So this is a good option for you to use if you are going to look at bringing Kafka managed data into ClickHouse. So that's what I wanted to call out. So a quick conclusion here. Basically, logs are everywhere. Everyone uses logs, and most of the cloud native applications actually print out, emit quite a lot of logs. So, and you do need to do analytics. If you can do analytics on top of your log, you can actually get really good insights out of your log. And for that, you need a cost-effective yet scalable way to analyze your logs. And we just discussed about one way to do that using ClickHouse and Kafka, two open source solutions that anyone can easily put together and create a working log analytics system.